Hello guys, so welcome back to this channel. In this video I'll be teaching you guys how to solve questions pertaining to electric potential as well as electric potential energy. Okay, so these are exam based questions. Now I will start with the fourth question first, okay, before I go to the first question. Okay, so in the fourth question I said, what is the electric potential at the center? Okay, they say what is the electric potential at the center of a square shown below. Okay, so at first need to study the square. Okay, look at the square very well. Okay, so they're asking us to calculate the electric potential acting at what? They're asking us to calculate for the electric potential as the center of what? As this point here. And this point is at where? Is at the center of the square. Now, if you look at it, if you look at the square very well, you find out that there are four charges in this square. Let me understand. So this is charge 1, this is charge 2, charge 3, and charge 4. Now you find out that charge 1 is a positive charge. You didn't say it's a positive charge, right? Then charge 2, you see a negative sign here. So it's to tell you that this charge is a negative charge. Charge 3 is a positive charge. Then charge 4 is a negative charge. Okay, so they're asking us to calculate the electric potential at this point. Okay, so that is just it. Now if you look at it very well, find out that these are the distance. Okay, so from the first charge to this point, from the second charge to this point, from the third and the fourth to this point, find out that these are the distances, right? Yes, these are the distances in respect to this point. Now you find out that this distance, all of them, they are equal. I don't understand. Apart from that, you all know that all the sides of a square are all equal, right? Yes. So apart from that, you find out that the arrow 1, arrow 2, arrow 3, then arrow 4. You find out that the distances are all equal, right? Okay. So how are we going to calculate for the electric potential at the center here? It's very easy. So if you look at it very well, we are dealing with more than one electric potential, right? Yes. So to get the electric potential, because there are four charges here, right? So to get the electric potential on this point, we use superposition. It's very easy. So the total to get the electric potential is very easy. Remember, electric potential is what? Is a scalar quantity. It's a scalar quantity. So scalar quantity, we add them. To get their total, we add them, right? Since there are four charges, therefore there are four electric potential. So to get the total actually at this point, we sum the electric potential due to charge 1, we'll sum the electric potential due to charge 2, electric potential due to charge 3, as well as electric potential due to charge 4. So when we add everything, we get the electric potential at this point. Because why? Because there are four charges acting on this point. So that's just it. So what I'm going to do is very easy. So the electric potential, the total electric potential acting at this point is equals to what? Electric potential due to charge 1, right? Plus electric potential due to charge 2, plus electric potential due to charge 3, and plus electric potential due to charge 4. Okay, so apart from that one, you find out that distance from charge 2 to charge 3 is what? Is 1 meter, right? Then what does that tell you? Since this diagram is a square, remember this all the sides of a square are all equal. Therefore, here is still from charge 3 to charge 4 is still what? Is 1 meter. Distance from charge 4 to charge 1 is still 1 meter. Distance from charge 1 to charge 2 is still what? Is still 1 meter. Okay. Yes. So total electric potential is the electric potential at this point is equals to the electric potential due to charge 1, charge 2, charge 3, and charge 4. Okay. Yes. Now, what is the formula for electric potential generally? The formula is equals to what? K times the charge divided by what? Divided by the distance, right? So this is the formula. Okay. So let's look for the electric potential due to charge 1 first. All right. So let's do it. Okay. So V1. Okay. So once we get each of the electric potential, then we add all of them. We'll get the total distance. So let's do it. So V1 will be equals to what? Okay. V1 will be equals to KQ1, right? Remember, the formula for electric potential generally is what? Is KQ over distance, right? Yes. Or you can put arrow. So it's still the same. The arrow means distance. Okay, so KQ1 divided by what? Arrow 1, right? Yes. Okay. So all right, so let's continue. Now V1 will be equals to what? We all know K. K is what? K is 9 times 10 raised to the power 9, right? Then times Q1, charge 1, which is 1 nanocoulomb. Now this NC, this means nano, okay? Nano, why this one is coulomb, the SI unit of charge. Now nano, I've told you guys say that nano means what? 10 raised to the power what? Minus 9, okay? Why micro is something like, micro is like this. Micro means 10 raised to the power what? Minus 6, okay? So this is nano, all right? So that is, nano means 10 raised to the power what? Minus 9, right? So 9, K is what? 9 times 10 raised to the power 9 times 10 raised to the power 9, then times charge 1 is what? 1 1 nanocoulomb. So that is 1, then times n, which is nano, is what? 10 raised to the power minus 9, right? Yes, then divided by what? R01. Now what is R01? What is distance from this charge to this point? Okay, what is distance? Remember, we all know that the distance from here to here is 1, from here to here is 1, from here to here is 1, from here to here is 1. That is from charge 1 to charge 2 is 1, from charge 2 to charge 3 is 1, from charge 3 to charge 4 is 1, from charge 4 to charge 1 is 1. Now, what about from charge 1 to what? To the point at which they are acting on. The one from this place to here, that is distance we are dealing with. We are not dealing with this distance. I don't know if you understand. We are not dealing with that distance. With respect to this point, we are dealing with this distance, right? So this is R1. Now, what is R1? The R1 is not specifying. They didn't give us R1 in the question. Remember, I told you guys that R1, R2, R3, R3, R4, they're all the same, right? That is, they are equal. So they didn't give us R1. Okay, so now let's look for R1. In the end of the day, once we get R1, we can, since all of them are equal, R1 is the same as R2, R3, R4. Okay, so let's get R1. So it's very easy. Okay, so we are going to use Pythagoras theory. So how are we going to do it? Okay, so how we're going to do it is very easy. Now if you look at this very well, this is square, right? Yes, this is square. All right, so this is square, right? This is square. So remember, this part of a square like this, look at it. This part of a square like this. Look, okay. This part like this. Okay, that is this part is what? Is a right angle triangle, right? Okay, it's a right angle triangle, right? Yes. So this part is a right angle triangle. Okay, then this straight line. Okay, so this straight line. All right, I'm coming. So this straight line. Okay, let me see. All right. Okay, let's continue. So this straight line, okay, this is straight line, right? Then if you look at it very well, this straight line and like this, this is a right angle triangle, right? Yes, this is a right angle triangle from here like this. So here to here is a right angle triangle, right? Yes, right angle triangle. I'm coming. Right angle triangle, right? Same also this side like this and this other one. It's still what? It's still a right angle triangle. It's still a triangle, right? Yes. So we have two shapes inside here. I mean, we have one shape. Both of them are the same. Right angle triangle, right? So like this. This is a triangle, right? This is a triangle. Right angle triangle. Then this other one is still a triangle, which is this one, right? Yes. So they are the same. Okay. So let's use this one. All right. It's still the same thing. Okay. Now, so stay with me. We are dealing with this one, right? Yes, I'm dealing with this one. Okay. So this point, this will be the point, right? This will be the point, right? Then if this is R1, this is R2, and this is R3, this is R4. Now just focus. We are dealing with this place, right? So let me tell you that from here to here is what? Is R4, right? Then from this place to this place is R2, right? Is R2, okay? Right? Yes, okay. So let's continue. Now, this is a right angle triangle, right? This is a right angle triangle. So you can call this place B. We can call this place B. We call this place A. Then we'll call this full place, this full line. We can call this full line arrow. Okay. Yes, we can call this full line arrow. Remember, we want to get this little letter, this arrow one. Arrow one. We want to get arrow 2, want to get arrow 3, want to get arrow 4. Remember, they are equal, right? So if you get one of them, you automatically have gotten everything. Okay, so we can call this full straight line arrow, which is the hypotenuse, right? Why this one is the adjacent, why this one is what? The opposite. So this is AB arrow. So let's look for arrow. Now, apart from that, if you look at it, arrow is equals to what? Arrow is equals to, look at it very well, arrow is equals to um 2, okay, is equals to arrow 4 and plus arrow 3, right? And arrow 2, right? Yes, remember both of them are equal. So let's just look for arrow first. Okay, let's just look for arrow first. All right. So let's do it using Pythagoras theory, right? So if you're looking for arrow, according to Pythagoras theory, arrow square will be equals to what? A square, right? Plus what? Plus B square, right? We're looking for arrow, right? So arrow square will be equals to, now where is A? Remember, I told you guys, this is A, right? This part is A, this part is B. Remember, I told you guys that from here to here is 1. Similarly, from here to here is still 1, right? From here to here is still 1, from here to here is still 1, because this is a square. All sides of a square are equal. So from here to here is 1. So A is what? A is 1. So 1 square, right? Then plus B, from here to here, which is, that is B, right? B is still 1, right? So 1 square. So 1 square is 1, plus another 1 square is 1, right? So everything here is 1, right? The square of 1 is 1, the square of 1 is still 1, right? So 1 plus 1 gives us 2. So therefore, arrow square is equals to what? Is equals to 2, right? Are we done yet? No. So we're looking for arrow, so we take the square root of both sides. So this square will cancel this square root. Therefore, arrow is equals to what? Root 2, right? Yes. So I've gotten our arrow to be what? Gotten our arrow to be what? Arrow is equals to what? Root 2, right? Right? Yes. Arrow equals to root 2. Okay. Now, since we have gotten our arrow, right? So let me clean this place. All right. Are we done yet? No, I want to get these distances. This distance. Now, if you look at it very well, if you look at it very well, let me clean this place. If you look at it very well, you find out that this two place is arrow, right? This two place is arrow, and half of arrow will give us, if you take the half of arrow will give us each of these little arrow, right? Now before that, let me not confuse you guys. Okay, this is arrow 1, right? This is arrow 2, this is arrow 3, this is arrow 4, right? Yes, remember I told you guys that from here, distance from here to here is arrow 1, from here to here is arrow 2, from here to here is arrow 3, from here to here is arrow 4. And I told you guys that this distance they are all equal. I don't even understand. They are all the same. They are all equal. From here to here is equal. From here to here is the same as this. So therefore, we can do something like this. We have already gotten our this one. We have already gotten into. So therefore, arrow 1 is equals to arrow 2, right? Look at it now. Arrow 1 is equals to arrow 2, right? Yes. From here to here is the same thing. 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 So arrow 1 is equals to arrow 2. Arrow 2 is still, which is still equals to arrow 3, which is still equals to what? Arrow 4, right? Yes, so you can just call all of them arrow. Let me understand, because they are all equal, they are all the same. From here to here is the same as this. Let me understand. So you can call all of them. You can just call all of them arrow. Okay? Yes, because they are the same thing, they are equal. So you can call all of them arrow. Okay, so you can call it little arrow, right? Yes. So therefore, if here is arrow, here is still arrow. Right? Here is arrow. So this capital letter arrow, which is this straight line, half of it will give us the little letter arrow, right? So therefore, arrow, this big letter arrow is still equals to what? It's still equals to I'm coming. Still is half of what? I'm coming. No, that is, so therefore this two arrow, this big arrow is equal to what? 2 of this. It's equal to 2 of little letter arrow now, right? Yes, because if you look at it very well, this capital letter arrow is made up of 2 arrow. That is from here to here is 1 arrow. From here to here is 1 arrow. Then from here to here is still another arrow, right? Yes. So therefore, this capital letter arrow is made up of 2 arrow. Is equals to 2 arrow, right? Look at it. From here, if we draw this arrow, this is capital letter arrow. I'm coming. This is capital letter arrow, right? And how many arrows do you see inside this line? From here to here, with respect to this point is 1. Then from here to here is still another 1. Right? Therefore, arrow is equal to 2 arrow, right? Don't forget that each of those arrows, they are all equal, right? So therefore, capital letter arrow is equal to what? 2 of small letter arrow, right? Yes. Are we done yet? No. Okay. So don't forget that this capital letter arrow is equal to what? Root 2. So in place of this, remember arrow is equal to root 2, right? Well, we still know that arrow is equal to what? 2 of this arrow, right? So in place of this capital letter arrow, put what? Put root 2, right? We put root 2. So root 2. All right. What are we looking for? We're looking for what? This small letter arrow, because that is distance that is the distance we are going to use. So what I'm going to do, divide both sides by 2, right? This one will cancel this. Therefore, r is equals to root 2 divide 2, right? So if you press your calculator, root 2 divide 2. Let me put it in decimal form. Is equals to what? 0.7071. Therefore, r is what? Is equals to, so therefore r is equals to 0.7071. Therefore, from here, remember I told you guys that r1 is still equals, they are all equal. It's still equals to r2, it's equals to r2, it's still equals to r4. Therefore, they are all, we can just call them all of them r because they are all equal. So they are all equal, right? They are all equal. So from here to here is 0.7071. From here to here is 0.7071. Same thing from here, same thing from here as well. Okay, so they are all equal. All right, so our V1 will be equals to 9 times 10 raised by 9 times 1. Charge 1 is 1, 1 times 10 raised by minus 9, right? Then divide by arrow 1, which is same as arrow, all of them are equal. So arrow is what? Is 0.7071. So if we do everything, let's do it. Let's do everything. Let's do it. So 9 times 10 raised by 9, then times 1 times 10 raised by what? Minus 9. Then divided by this minus 9. Okay, so you guys said earlier minus 9. Okay, due to is nano, right? So divided by, yeah, that's 0.7071. So if we do it, we get V1 is what? Is 12.7. So V1 is equal to what? 12.7. Okay, 73. Okay, so I went our V1. Remember what are we looking for? We're looking for a total electric potentiality at this point, right? So V1 is 12.73. Okay, so let me just write it somewhere here. Okay, so V1 is 12.73. Okay, so let's look for V2. All right, so let's look for V2. V2 is still the same formula, right? But this one will be charge 2. Then this one will be arrow 2. Remember, arrow 2, they are still equal. They still the same thing as arrow 1, right? They are all equal. So we can just put arrow like that, right? Because it's the same thing. Arrow 1, arrow 2, arrow 3 are all the same. They are all 0.7071. Okay, so V2 because what? K is what? 9 times 10 is 9. Then times charge 2 is what? Minus 2 times what? Nano is 10 raised by minus 9, right? Then divide by what? Arrow 0.7071, right? So let's do it. Okay, let's do it. So 9 times 10 raised by 9, then times minus 2 times 10 raised by what? Minus 9, then divide by what? 0.7071. So when we do it, we get minus 25.45. So V2 is negative electric potential, which is minus 25 point, okay, approximately minus 25.5. Okay, now let's look for V3 and V4. Okay, let me be fast. Okay, so V3 will be charge 3 is what? Charge 3 is 3, right? It's 3, then times this nano, right? Nano is 3, so minus 9, right? Remember, this arrow 3 is still, they are all equal, right? It's still 0.7071. Arrow 3 is still 0.7. Okay, this would be arrow V3, right? V3, right? Yes, still the same thing. Okay, so this distance, this from here to here, is the same thing, right? It's still 0.0071. So let's do it. So 9 times 10 raised by what? 9. Then times, okay, this is not minus now. This one is, remember, this is a plus, it's positive, right? So times 3 times 10 raised by what? Minus 9, right? Then divide by 0.7071. So when we do it, we get 38. Okay, so V3 is what? V3 is 38. It's 38.2. Okay. Then let's look for V4. Turn here to V4, then turn here to Q4, charge 4, right? Charge 4. Then we clean this charge, right? Remember, K is constant, 9 times 9. Then the distance, arrow 4, from here to here, which is arrow 4, is still the same. Remember, I told you guys all of them are equal. So it's still 0.0071, right? Charge 4 is what? Is minus 4, then times nano is what? 10 raised by minus 9, right? Yes. So let's do it. Okay. So let's do it. So 9 times 10 raised by 9, then times minus 4 times 10 raised by what? Minus 9. Then divided by what? 0.7071. So we get minus 50.9. Okay, so V4 is what? V4 is minus 50.9. So what are we going to do next? So I've gotten each of the electric potential, right? So we add them, right? So that is just easy, very easy. So if we add them, we get our final answer. So V1 is what? V1 is 12.73, then plus, now V2 is minus, right? Is minus 25.5, then plus V3 is what? Is 38.2, then plus V4 is what? Is minus 50.9. So if you press everything in the calculator, let's see what is our answer. Okay, so let's do it. All right, so let's do it. So 12.73 plus bracket minus 25.5 bracket close, then plus 38.2, then plus bracket open minus 50.9. So bracket close. So our answer is minus 25.47, which is approximately minus 25 plus 47 is approximately what? Minus 25.5. So vote. So this is our answer, minus 25.5. So that's just it, okay? Yes. So that's how to solve question like this. Very easy, okay? Yes. So now previous class I also told you guys now let's say for example, let's say now when the point at which they are acting on, it depends on the point actually. Yes, it depends on the point. Now let's say the point they are acting on, let's say I'm coming, we are done with this question, okay? So let's say it just depends on the point actually. So let's say there are three charges. Now let's say we call this one charge one, charge two, then charge three. Now let's say they're acting at here. It's still different. It's still the same way. Still the same way. Okay. Yes. Let's say they give the distance from here to here. Let's say give the distance from here to here. I've explained that earlier. Let's say give us from here to here is 2. From here to here is 2. Let's say it's 4. Let's say from here to here is 3. From here to here, let's say it's still 2, for example. Now, what the only thing you are going to do, remember, it's always with respect to the point. The point at which they are acting on. The point. So it's still easy to get our arrow one, to get our total V, it will be V1. Our V1 will be what? Our V1 will be KQ1, right? Over arrow 1, right? Now, what will be our arrow 1 here? This is Q1, right? Q1, K is constant. Our arrow 1 will be 2. Remember, it's always with respect to the point. I don't know if you understand. Our Q1 can never be 4 because there's no point at which we are dealing. There's no point here. It's always with what? With respect to this point. Right? From distance from here to here will be what? Distance from here to here will be 2. Now let's say we want to look for V3. V3 will be what? KQ3 divided by what? Arrow 3. Now what will be this Q3, right? Q3. Then what will be our arrow 3? That is from this charge to what? To this point is what? This will be our arrow 3, which is 3. Now what about charge 2? Charge 2. To get the V2 will be what? Okay, KQ2 over what? Arrow 2. What will be arrow 2? Remember, it's always with respect to the point. Right? Our arrow 2 will be like this, okay? Will be like this. So this will be our arrow 2. And to get arrow 2, we use Pythagoras theory. I've explained it earlier in our previous class. So it just depends on the point. Now in this question that they gave us earlier, there were 4 charges. Okay, there were 4 charges, and all of them were acting at a point. And in the center, right? In the center. So we got to use Pythagoras theory to get the distance. Right, so that is just it. So the answer is on minus 25.5 volts. Okay, now let's move to question 1. Okay, so let's move to question 1. Okay, all right. So let me be fast. All right. So question 1. Now, question 1 is they said. Okay, so question 1 they said Professor John placed 2-point charge. Place 2-point charge. Let's because one Q1 then Q2. These are the point charges. Okay, Professor John placed 2-point charges such that Q1 is what? Q1 is 3 microcoulomb. Okay, Q1 is placed at 0. So this is the origin, which is 0. Right, the distance. So we place at 0. Okay, and charge Q2 is equals to what? 2 microcoulomb. 2 microcoulomb, right? It's located at 50 centimeter. So from here to here is what? So it's located at 50 centimeter, right? So this charge 2 is located at 50 centimeter. Now they say calculate the work done by an external force to bring a charge Q3 of magnitude 1.5. Now let's say this is a charge Q3, the magnitude of the charge is what? Q3 is what? Is 1.5 microcoulomb, right? They said, okay, calculate the external force to bring a charge Q3 of magnitude 1.5 from distance of 100 centimeter. Okay, I mean, like it looks like they made a mistake in this question. Okay, the way it's supposed to be is to calculate the work done by an external force to bring the charge from infinity to this point. I don't know if you understand. So if you look at the question if you look at the question, they say calculate the work done by an external force to bring a charge Q3 from okay from 100 centimeter. Okay, from 100 centimeter. Okay, I think it's supposed to be calculate the work done by the external force to bring that is how it's supposed to be, to bring the charge Q3 from infinity to what, to 100 centimeter. So that is just it. Okay, but to bring a charge of magnitude from 100, okay, it can still be like, let's, okay, still correct. Okay, so 100 centimeter. All right, so it's still correct. From 100 centimeter, it's correct. Okay, so 100 centimeter, 50 centimeter, 0. So charge 1 is 0, located in the origin, 0 position. Charge 2 is 50 centimeter. Charge 3 is located in the 100 centimeter. So these are their magnitude. Okay, so what are they telling us to look for? They tell us to look for the work done. They tell us to calculate for the work done. Where is it? Calculate the work done by an external force to bring this charge from 100 centimeter. Okay, so we want to calculate for what? Work done to bring this charge. The work done to bring this charge. So yes, we also that's telling us look for work done. Now, how are we going to get, which formula are we going to use to calculate for the work done to bring this charge from 100 centimeter? Which formula are we going to use? We're going to use electric potential. Remember, electric potential is what is the work done, right? Is the work done divide what is right charge, right? If you simplify it further, we know that we'll get V equals to KQ over D, right? Yes, so this is the formula for electric potential. This is also another formula. So this is also a formula for electric potential. If you derive this further, you get this. So they are the same thing. Okay, so now what are we looking for? We're looking for work done, right? Work done. So we use electric potential to get the formula of work done. Now, remember, electric potential is equals to work done over charge, right? So if we cross multiply, work done be what? Work done be equals to electric potential times what? Times charge, right? Yes, times charge. Now remember, also V, which electric potential, I also tell you guys the electric potential is what? K times the charge over the distance, right? Yes. Remember, we're looking for what? Work done. Work done is equals to electric potential times charge. Now, where's electric potential? Electric potential is what? Is K times charge, then this other charge again, they divide by what? Distance, right? Therefore, work done is equal to K Q1. You can call this one Q1, you can call this other one Q2, right? So this is formula for work done. Okay, so therefore, we're looking for work done, right? So work done will be equals to what? K Q1, Q2 divided by what? D. So this is work done, okay? Yes. Now, I want to explain something. Let's look at this very well. If you look at this question very well, there are how many charges here? There are 3 charges, right? Yes. And they're asking us to calculate for the work done by force. Let's calculate the work done to bring this charge 3 from what? From 100 centimeter. Okay. So we want to calculate for the work done to bring this charge 3 from 100 centimeter. So the work done to bring it. Okay. So if you look at it very well, found that these are 3 charges, and these first 2 charges, they are acting on this charge. Okay, look at it. Look at the question where it said calculate the work done to bring charge theory, right, from 100 centimeter. The work done to bring it, right. So to calculate the work done will be due to what? Look at it very well. Charge 1 is acting on charge 3. Charge 2 is also acting on charge 3. Okay. Yes, they are on charge 3, right? They are on charge 3. So to calculate the work done, we want to look at total work done due to these 2 charges acting on what? On charge 3. Okay. So the total work done will be what? The total work done. The total work done will be the work done between charge 1 and what? Charge 1 and what? And charge 3. Then plus the work done due to what? Charge between charge 2 and what? And charge 3, because these two charges are adding on this charge, right? Between charge 2 and what? Charge 3. So that is just it. Okay, so let's do it. So total work done will be equals to what? What is work? What is formula for work done? Formula for work done is what? K Q1 Q2, right? So since we are dealing with charge 1 and charge 2 here, I mean charge 1 and charge 3, this one will be charge 1, this one will be charge 3. Then divided by this is this distance, right? Divided by distance. Now this distance is from where? It's from charge 1 to what? Charge 3. Distance from charge 1 to charge 3 is what? From charge 1 to charge 3 is what? Is 100 centimeter, right? Yes. So we can do something that you say 1 2 and 1 3, right? So this 1 3 means that distance from charge 1 to charge 3. Then plus work done due to charge 2 and charge 3. Right, so what is formula for work done? Work done is what? This is formula for work done. K Q. Since we are dealing with Q2 and Q3, this Q1 will be what? This will be Q2, then this will be what? Q3, right? So we are dealing with Q2 and Q3, right? Q3, then divide by what? Now, this distance will be the distance from what? Charge 2 to what? Charge 3. So charge 2 to charge 3. So this is formula. So this is what we're going to do. So therefore, the total work done equals to what? KQ1, Q2 divide distance from charge 1 to charge 3 plus KQ2, Q3 divided by what? Distance from charge 2 to charge 3. So that's just it, okay? Yes. So yeah, so that's what we're going to do. All right. So this is formula. All right. So this formula we're going to do just to input all the values there, we get our answer. All right. So that's just it. Now before then, this if you look at it very well, these distances they are what? They're in centimeters. So we need to convert it to what? To meter by dividing by 100. So if you divide 50 by 100, you get to now be what? To now be 0.5, right? So now be 0.5 meter. Okay, here will be what? Here will be 1 meter. 100 divided 100 will give us 1. So here will be 1 meter. Okay. So if we have converted from centimeter to meter. All right. So let's continue. Okay. So if you look at this formula very well, we can just do it, input each of them. Input it, add everything, get an answer. Okay. So let's just do it. All right. So now let's do it. Okay. K is what? K is 9 times 10 is 9, right? Then times charge 1 is what? Charge 1 is 3 microcoulomb. Micro is what? 10 raised to the power minus 6, right? Then times charge 3. Charge 3 is what? 1.5. Micro is, remember, micro is 10 raised to the power minus 6. So charge 3 is what? 1.5. Then times 10 raised to the power minus 6, right? Then divided by what? Divided by distance from charge 1 to charge 3 is what? From charge 1. Distance from this place to charge 3 is 1 meter. So it's 1. So the 1. Okay. So 1. Okay. Then plus okay. K again. K is what? 9 times 10 raised to 9. Okay, I would have done it like fast just because of some persons. Okay, so I'm just doing it step by step. Okay, so let's continue. So this is 9 times 10 raised to 9, then times Q2 is what? Q2 is 2 microcoulombs, right? So 2 times 10 is minus 6. Okay, minus 6. Then times Q3 is what? Q3 is 1.5 times 10 is minus 6. Then divided by what? Coming. Then divided by the distance. Alright, so distance from charge 2 to charge 3 is what? Remember, charge 2 is at 0.5. Charge 1 is at where? 1. So from here to here, what will be distance? 1 minus 0.5 will give us 0.5. So from charge 2 to charge 3, distance is what? Is 0.5. So 0.5. So we are going to do this. We add it with what? This. We get our total work done. So it's very easy. So let me just be fast. Let's do 9 times 10 is 9. Raised to 9. Then times 3 times 10 raised to power minus 6. Then times 1.5 times 10 raised to power minus 6. Then divided by what? 1, right? Then plus this other one again. Plus 9 times 10 raised to what? 9. Then times 2 times 10 raised to minus 6. Then times I'm coming. Okay, then times 1.5 times 10 raised to what? Minus 6. Then divided by what? 0.5. So if we do it, we get our total answer, total work done is 0.09945, which is something as 9 times 10 raised to the minus 2. Okay, 9 times 10 raised to the minus 2, or we can just say, okay, yeah. So our answer is what? We can just say, okay, our answer is 0.0945. Okay, so that is our answer, 0.0945 joules, or 2, or we can say 9.5 times 10 raised to the minus 2. Okay, this one is still correct. Okay, yes. All right. So work done is what? Work done is 0.0945 joules. Okay, if you want to turn it to standard form, K12. So now be see something as 9.45, right? Then times 10 to the minus 2. So if we what they call it, to approximate this, we get something like this: 9.5 times 10 to the minus 2. So it's the same thing. So let's go with this answer. So this is our answer, okay? Joules. So this is our answer. All right. Now let's go to the next question, which is question 2. Okay, question 2 is continuation of, is referring to question 1 as well. All right. So call me. Oh God, I clean it. Okay. So question 2, let's say if the professor was to calculate the total potential energy of the system of 3 charges in question 1 above, what will be the value? Okay, they are telling us to calculate for the potential energy of the system. So, okay, remember charge 1 is located at 0 meter, then charge 2 is located at 0.5 meter, right? Then charge 3 is located from where? Charge 3 is located in 1 meter, right? At 1 meter, right? We are referring to question 1. Okay, remember charge 1 is 3 microcoulomb. Charge 2 is 2 microcoulomb. Then charge 3 is 1.5 microcoulomb, right? Yes. Now in this question, I tell us look for this. They look at it, they say if the professor was to calculate the total potential energy of the system of 3 charges in question 1 above, what would be the value? We are looking for potential energy of the entire system. So it's very easy. Okay, so it's very easy to calculate from potential energy. Remember, what is the formula for work done? I gave you guys. Work done is equals to what is it again? Okay, work done is equals to K Q1 Q2 divided by what? Rho, right? Divided by distance. Okay, yes. Now remember, potential energy and work done, they are like, should I say, kind of the same. Okay, we can use energy in place of work, right? Work energy is equals to work done, right? Energy equals work equals energy. So yes, so since energy is equals work is also equal energy, right? Therefore potential energy is equals to what? Work done, right? Therefore if work done is equals to this, therefore potential energy will still be equals to what? Will still equals to this, right? So this is formula for potential energy, okay, which is kq, k times the 2 charges, then divided by distance between the charges. Okay, so now to calculate for the potential energy of the system, if you look at it very well, these 3 charges, they are all acting on each other. Look at it. Charge 1 is okay. Let's do something like this. Charge 1 is acting on charge 2. Also, charge 3 is also acting on charge 2. Right? Similarly, charge 2 is acting on charge 1, as well as charge 3 is also acting on what? On charge 1. Right? Also, charge 2 is acting on charge 3, charge 1 is also acting on what? On charge 3. Right? So to get the potential energy of the entire system, to be potential energy, okay, to be the potential energy between charge 1, charge 2, plus potential energy between charge 1, charge 2, between charge 1 and charge 3, then it can also be plus potential energy between charge 2 and 3. Okay, so that's just it. Okay, because all of them are acting on each other, right? So that is just it. All of them act on each other. Therefore, potential energy of the entire system will be potential energy of between charge 1 charge 2 plus potential energy between charge 1 and charge 3 plus potential energy between charge 2 and what charge 3, right? Because they are all at each other. So let's do it. Formula of potential energy. Okay, since we're dealing with charge 1 and charge 2, this one will be what? Ku1, then okay, Ku2, right? Then divided by what? This the distance will be from where charge 1 to charge 2, right? Then plus potential energy is K, okay, the charge will be what? Charge 1, then charge 3, right? Then divided by what? Distance from where? From charge 1 to charge 3, right? Then plus potential energy is still equals to what? Ku, okay, Ku what? I think we're dealing with charge 2, right? Then and what? Charge 3. Then this distance will be from where? From charge 2 to charge 3, right? So this is the formula. So if we add everything, we get the potential energy of the system. Okay, so it's very easy. All right, so let me clean this place. Okay, so let me clean this place. So let me just be fast, okay? So I want to just simplify everything. If you input all the values into it, you get your answer. We all know K to be 9 times 10 to 9. Charge 1 is 3 times 10. Charge 1 is 3 times 10 to the minus 6, right? Remember, this is micro column. Micro is 10 to the minus 6. Charge 2 is 2 times 10 to the minus 6, right? We all know charge 3. Charge 3 is 1.5 times 10 to the minus 6. The distance from charge 1 to charge 2 is charge 1. Distance from charge 1 to charge 2 is what? 0.5. The distance from charge 1 to charge 3 from here to here is from charge 1 to charge 3 is what? Is 1 meter. The distance from charge 2 to charge 3, is what? 1 minus 0.5 will give us 0.5, so it's 0.5, right? So if you repeat everything, you get an answer. Okay, so now I want to just simplify. Let me simplify everything. Now let's simplify. What is common between these theory is what? Is K, right? So the potential energy of the system will be because where is common? The things that is common here is K, right? It's common. Okay. Then we'll do something like this, bracket open. Then since K is common between, I just want to do this so that to conserve time, right? Because cannot just be writing everything to like this. Okay, so K is common. Alright. So let's want to simplify everything. Then we'll now something like the Q1, Q2, then divide by what? The distance from 1 to 2, then plus Q1, Q3 divided by what? Distance from 1 to 3, then plus Q2, Q3 divided by distance from 2 to 3, right? So this thing is something as this, right? Because if you multiply this with this, you get this. If you multiply this with this, you get this. You do this and this, you get this. So that is just it, okay? So let's continue. Potential energy because what is K? K is on 9 times 10 is on 9, right? Then bracket open. Charge 1 is what? Charge 1 is 3 microcoulomb. So 3 times 10 is on minus 6, right? Times charge 2. Charge 2 is what? 2 microcoulomb. 2 times 10 is on minus 6, right? Then distance from charge 1 to charge 2. From charge 1 to charge 2, the distance is 0.5. Okay. Then plus charge 1 is, we know charge 1 is 10, 3 times 10 is on minus 6. Charge 3 is 1.5 times 10 is on minus 6. And divided by what? Distance from charge 1 to charge 3. From charge 1 to charge 3. This distance from charge 1 to charge 3 is what? Is 1 meter. So 1 meter, 1. Okay, then plus the last part. Charge 2 is what? Charge 2 is 2 times 10 is on minus 6, right? Then times charge 3. Charge 3 is what? 1.5 times 10 is on minus 6. Then divided by what? Distance from charge 2 to charge 3. Okay, so I'm coming. Now this is charge 1, right? This is charge 2. Then from charge 1 to charge 3 is what? Is 1 meter. We know that one, right? Okay, so distance from charge 2 to charge 3. From this charge 2 to charge 3, what is the distance? 1 minus 0.5 give us 0.5. Okay, so still 0.5. Okay, so if you do everything with your calculator, you get the potential energy of the system. So let's do it. Okay, so 9 times 10 raised to 9, then bracket open. Okay, 3 times 10 raised to minus 6, then times 2 times 10 raised to minus 6 divided by what? 0.5, right? Then plus 3, okay, plus 3 times 10 raised to the power minus 6. Okay, then times 1.5 times 10 raised to the power minus 6. Right, divided by what? 1. Then last part plus 2 times 10 raised to the power minus 6. Then times 1.5 times 10 raised to the power minus 6. Divided by 0.5. Okay, divided by 0.5. Answer is 0.2. So the potential energy is what? Of the system is what? 0.2 joules. Or you can say 2 times 10 raised to what? 2 times 10 raised to minus 1. Okay, 2 times 10 raised to minus 1 is still something as 0.2. Okay, so this is our answer. Okay, so the potential energy of the system is 0.2 or 2 times 10 raised to minus 1 joules. Okay, then the last part, question 3. Okay, let's solve this last question. Question 3. An electron, this is the mass, okay, of mass 9.1 times 10 to the minus 31 kg, okay, minus 31 kg, is between two parallel plates. Let's say this is parallel plate. All right, so between two parallel plate conductors separated by a distance of 50 centimeter. So the distance between these two parallel plates is 50 centimeter. Okay, if the final velocity of the electron is 10 raised to power 8, so the velocity of the electron, the final velocity is what? 10 raised to power 8 meter per seconds. Okay, let's say calculate A, the work done on the electron. Yeah, so the answer to calculate for work done. So it's very easy. Okay, so they're giving us velocity of the electron. The distance between two plates is 50 centimeter. Now we need to convert this 50 centimeter to what? To meter by dividing by 100. So if we divide 50 divided 100 will give us 0.5, right? 50 divided 100 give us 0.5. Therefore, the distance between these two plates is 0.5 meter, right? So the distance, we have distance of 0.5 meter. So so the electron travel from here to here. So this from a distance of 0.5, right? It travels a distance of 0.5 meter. Now, okay, let's say you can look for the work done, work done. Remember, the mass of electron is what? Let me just bring out the parameter. Mass of electron is 9.1 times 10 raised to the power minus 31 kg. Okay, so we are looking for work done on the electron. Now, it's very easy. Remember, work and energy, they're equal, right? Yes. So work equals energy, energy equals work. I don't know if you understand. So look at it, asking us to calculate for work, the work done on the electron. So if you look at the parameters they give to us, look at the parameters they give to us, they give us velocity, they give us mass, right? So work done, we all know that work done equals energy, right? Work done equals energy. So you can say work done equals energy. Energy can be kinetic or potential. So we can say work done equals to kinetic energy, right? Work done equals energy. Energy equals work done, right? The energy here is what? Kinetic energy. The electron is moving, right? Kinetic energy. Okay, so once you get the kinetic energy, automatically got the work done. Okay, so kinetic energy, we all know that kinetic energy is what formula for kinetic energy? Half mv square, right? So we are going to go half mv square. So if we do everything here, we get our work done. So half then times the mass of the electron is what? 9.1 times 10 raised to the power minus 31, then times the square of the velocity, which is 10 raised to the power 8, then square. So if we do everything, we get the work done. So it's simple like that. So let's do it. So half times 9.1 times 10 raised to the power minus 31, then times bracket open, 10 raised to the power 8, bracket close, then whole square. So if we do it, how the work done on the electron, the work done on the electron is 4.55 times 10 raised to the power minus 15 joules. Okay, then let's calculate the difference potential difference between the two plates. Potential difference between the two plates, which we are looking for potential difference between the two plates, is very easy. Use electric potential. Okay, look at it. We've gotten work done, right? Gotten work done. Remember, what is electric potential? Electric potential. Remember, we know that electric potential is equal to kq divided by what? Charge, right? Yes. Now I also tell you guys that electric potential is something as work done divided by what? Removing a charge from infinity to particular point, right? Divided by what? Charge, right? Yes. So if we simplify this further, we get this. So these two formulas are the same. This one is got from this. If we break it down further, don't you understand? Okay, so we all know that the same calculate potential difference between two plates. So we know electric potential is equals to work done divided by what? Divided by the charge, right? Yes, divided by the charge. Okay, so V equals to work done by charge, right? Our V, that's what we're looking for. We are looking for potential difference or voltage, right? So work done, the work done got earlier was 4.55 times 10 raised to power minus, okay, times 10 raised to power minus 15, right? Then divided by what? Charge. Okay, yes, divided by charge. Now, what is the charge of electron? This divided by charge. What is charge of electron? I told you guys, charge of electron um is 1.6 times 10 raised to power minus 15, right? Yes. So no, minus 19. Sorry, 1.6 times 10 raised to power minus 19. 1.6 times 10 raised to power minus 19. Okay, so that is it. Okay, so if we divide it, let's divide it. Okay, so if we divide it, let's just divide it, we get this thing, get the potential difference. Okay, so all right, okay, let's do it. So 4.55 times 10 raised to power minus 15, right? Then divided by 1.6 times 10 raised to power minus 19. So if we do it, our answer is 28437.5. So the electric potential is 28437.5 volt. Okay, 0.5 volts. So this is our electric potential. Remember, they said the potential difference between the two plates. Okay, potential difference between two plates. I told you guys said that potential difference is different from electric potential. I told you guys that potential difference, which is voltage, is what is equals to change in electric potential. I don't understand. Change in electric potential. What we did here, we calculate for the electric potential. We calculate for the electric potential at calculate for the electric potential when the electron travels from this place to the other place, right? They calculate for the electric potential. Okay, they also calculate for potential difference, which is also known as voltage. Potential difference or voltage is what difference in what electric potential. So we use that formula to get our electric potential first. Our electric potential, the electric potential we got is V2, and V2 is what? Is 28437.5. Okay, so let's assume that this V1 is 0. Okay, so anything give, so this value, which is our V2, let's see, which is our V2, 28437.5, then minus, which is our V2. Let's call it, let's say please mind, let's assume that since the electron moves from this point, from this plate to another plate, look at it. They said an electron is between two parallel plates, okay, separated by distance. If the final velocity, that is, the electron move from this plate to this other plate. So this plate is of a lower potential, then move to a point of a higher potential. Okay, move from a point of lower potential to a point of higher potential. So we can call this part with the lower potential 0, then the higher potential to be this one. So this thing is minus 0, still give us this value. Okay, this value minus 0 will give us this value, 28437.5. Therefore the potential difference or the volt is what? 28437.5 volts. Okay, remember, voltage or electric or potential difference, the SI unit is still volt. Electric potential, the SI unit is still volt. Okay, so yes, so let's do the last one, which is which is the C part. They said let's calculate the electric field between the plates. Before we continue with this question C, they said the electric field between the plates. Now, this is our answer, right? This is our answer. Like the potential difference between the plates, right? The potential difference between the plates is 2000. Okay. I think that is 28,437.5. Okay, anyone. So 28437.5 volts, right? Yes. So which can still be the same, which can also be the same thing as what? I'm coming 1, 2, 3, 4, which is the same thing as 2.8 times 10 raised by what? 4 volts. The same thing, right? So yeah, now let's calculate for this one is correct, this one is also correct. Okay, so now let's calculate for the last part. They say the electric field between the plates. The electric field between the plates. Okay, this is okay, positive, 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 positive. Okay, so want to calculate for the electric field between the plates. This is negative, 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 negative. Okay, so let's do it. It's very easy. I've given you guys the formula earlier then. Okay, so what our vote, the work done got is this. Then our potential difference is this, right? Yes. Now they ask us to look for what? Look for look for electric field between the plates. Yes. So take note when I ask a question like this, I told you guys electric field. I gave you guys in our previous class. Electric field is still equals to what? Electric potential divided by what? Distance. I've told you guys. I've given you guys earlier. Then I explained why the formula is like this. So you can just go to our previous class under electric potential as a whole. Okay, under electric potential, you see where I give guys formula that electric field is equals to electric potential divided by what? Distance. Okay, so if we continue, our electric potential, remember this is our potential difference, right? Then when we calculate V2, which is our electric potential, is what? Is electric potential is this, right? Is this. So which is still the same thing as what? 2.8 times 10 raised by what? 4 volts, right? It's still the same thing. So electric potential is what? 2.8 times 10 raised by what? 4. Then divided by what? Distance. Distance between two plates is what? 0.5. Okay? So let's do it. So divide, I'm coming. Okay. So let's do divide by 2.8 times 10 raised power 4 divided by 0.5. So our answer is I think 1, 2, 3, 4. Okay. Is 5.6 times 10 raised power 4. Okay, so that would be our answer. 5.6 times 10 raised power 4, which is as 56,000. Okay. Yes. Okay, that is when we do this. Now if we use this value, let's say we don't turn it to standard form, we just use this as a normal value. Use that normal value 28437.5. We use our normal value. If you use this normal value, divide it by this thing. Let's do it. Okay, so 28437.5 divided by, I'm coming, divided by 0.5 will give us 56,875. Okay, so yeah, so this one is correct, this one is also correct. It says why this one is also correct, because if you turn it to standard form, 1, 2, 3, 4, turn it to standard form, that's like 5.6 times 10 raised by what? 4, which is this. 5.6 times 10 raised by 4 is 6 as well, 56,000. So it's just normal mathematical stuff. So these are you solve questions really pertaining to electric potential energy, yeah. Then electric field as well. When they are relating electric field to its electric potential and all. So that is just it.